thank you everyone to come here to support tonight's event. Without your attendance and coming to support our event will not make us so successful and wonderful. And we are proud to connect to the IEEE, and we are part of the IEEE society. And tonight's event is sponsored by the IEEE New York chapter of IEEE SMC, System Man Cybernetics Society, and sponsored by the IEEE student branch at Long Island University branch. It's my great pleasure to introduce tonight's keynote speaker, Dr. George Chang. Dr. Chang is a former chair of the Department of Computer Science, became the dean of the College of Natural Applied Health Sciences at Kean University in 2011. Let's have a big applause to welcome
Thank you. Thank you for the invitation, Dr. Chang. And I'm honored to be here tonight to talk to you about immersive technology. My background is computer science, and I have a lot of toys in my lab, a lot of computer scientists will wish to have. But I use all these toys for my teaching and for my students to do projects in. Okay, I'm going to show to you all these different tools and technologies that I've been using for over past 5-6 years. And I hope that this will give you some introduction to what's out there and what is possible. Especially, I believe this is the year of immersive technology to become very popular with many of the goggles that's coming out later this year. Okay. So immersive technology, well, when you think of immersion, there are different immersion. When you're reading a book, you actually immerse in that book, in the story. That is one form of immersion. But the type of immersion that I'm going to discuss tonight is not reading a book or immerse in an environment. For example, immerse in English-only like environment. Like you come into the United States, you immerse in English-like environment. No, that's not what we're talking about. We're talking about virtual reality immersion. So immersion in virtual reality is a bridge between physical and the digital world. Okay? The digital world is simulated world. It's fake. It's fake. Okay? So the digital world, sometimes we call this virtual world. Yeah. When you are playing video game, you're in that environment. Your brain is inside. Okay? But that is not the true immersion. Okay? To be truly immersion environment, you need a lot more technology to be involved. Okay? So I believe many of you have visited Disney World, right? There, in theme park, you can go into different rides. And this is an Avatar ride at Walt Disney. Okay? And you are in that environment, and you have sound effect. You might have smoke coming out, fire coming out at you. Is this a truly virtual reality immersion?
No.
Yes or no?
No.
No, this is not real digital immersion. Okay, because you're actually still seeing physical world. Okay, you are not in the real digital world. This is somehow semi-immersion. It make you believe that you're in that environment. In fact, you're still looking at the physical world. Okay. So, in order to achieve real virtual immersion in virtual reality, you have to change the perception of the user. Perception. What do we mean by perception? That means sight, sound, touch, smell, and taste. Okay? You have to get that impression of perception that you're actually in that environment. Yes?
There are a lot more.
Yes.
It's the basics.
Yes. Yeah. So sight, sound, touch, smell, and taste. Okay? So more technically, sight is visual, sound is auditory, touch is tactile, smell is olfactory, taste is gustation. Okay? At any point, if you have any questions, just ask. Okay? So when did virtual reality started? Does anyone know?
Well, now we do.
Yeah. It actually started in 1968. One of the first systems were actually built in 1968. Okay. It was by Ivan Sutherland and his student. If you don't know this person, that's fine. But he has a lot of students that has accomplished a lot. His student created a small talk language. His student became the president and the co-founders of Pixar, Disney, animations. Okay, these are all his students. He graduated many students. And he is the winner of Turing Award in 1988. Okay, Turing Award in 88. So he is a pioneer in this area. So in 1968, he started all these. Okay, how many of you have used any of these systems before? Some of you might have. Okay. Yeah. I picked this topic because I knew that not many students have exposed to this type of technology because they are very expensive. They're very expensive. So this is a system that he built like this. So it's immersion. You look through this goggle and you can see what the computer is displaying at very primitive sketch-like interface. Okay?
I have one question.
Yes.
You know, this sight, smell, taste, and so on and so forth. You transform them from the physical world to the digital world. So we need a kind of quantification. How do we quantify taste? How do we quantify smell?
Okay. Very good question. Well, let me ask you a question, okay? Which one out of these five you think is the most important to have this immersive
Visual, sight,
sight, right? Sight.
sight and sound.
Sight and sound. Okay.
Touch.
Touch.
On the five.
All five. You need all five.
Most important.
Okay. So the first one, visual, is very important. Most of our human brain is designed to do visual. Okay. Visual is very important. Okay. Sound, well, it depends. It depends. Okay. Touch, can you feel the object inside the virtual world? I mean, when you play video game, do you wish you can touch the other opponent?
Yeah.
Yeah.
Depends what type of object, right? Yes. So it's not so easy to achieve touch and smell and taste. In fact, most of the research is in the top three. Smell and taste is very hard to produce. It's very hard. If you go to a theme park, you might have smoke coming out of you and it creates some type of smell of volcano, for example. Okay, but that is very there's no variation. Let's say you have a taste of some type of object, fruits that you want to have a bite of food, pizza, to create the taste and smell instantaneously. It's not attainable at this time. It's not at this time. Okay, but the other three is all within reach. It's all within reach. Okay, technology is there. I could do all three, except the last two. Okay.
Is this then very subjective?
Yes. So a virtual reality or immersive system, once it's built, it depends who's using it. Some people will feel that I don't feel this is a good system. It depends who's using it. Depends who's using it. Yes. similar to any type of human interactive interface. How many people like iPhone interface? I would say majority of user likes iPhone, but not always 100%, right? Or there'll be some people who didn't like iPhone for some reason. Okay? For disabled person, you don't have fingers, it's going to be very hard for that person to use iPhone. Yes?
Yes, Doctor. I'm following on that question. Hard to quantify. When do you get there? When you mentioned the winning of the Turing Prize, reminded of Alan Turing. Do you think, or is there already something like a Turing test for virtual reality, when you'll put a person in and they won't know?
Whether real or not real?
Yeah.
Not yet.
But
Yeah. Not yet.
Okay.
Yes. So I'll go get to that later.
Thank
okay?
you.
So, in order to provide visual effect so that you feel that you're immersed in an environment, you need to see things in 3D in digital format. So you need some type of visual display. Okay? So the easiest thing is to use a goggle like this, a visor. Okay? This is the visor I bought 6 years ago. It was $1,600. I got 2 of these. I still have them. It was 800 by 600 resolution. I checked the price yesterday because I was preparing this presentation. Still at 1,600. I don't know why. Yeah, and it's not very good goggle by today's standard. Okay, so my student was using this to build games, to build that virtual reality simulated environment. Okay, and this only works on Windows XP. It doesn't even support Vista or Windows 8, 10. So I'm sure that many of you knew this. What's this? This is the Oculus. Okay, if you don't know this, Facebook just bought this company. Okay, Facebook just bought this. Okay? So if Facebook's buying this company, that tells you that this is the future that they are going after, virtual reality. Okay, how much is this device going to cost you? Does anyone know? I have one. I don't use it. I bought it for my faculty. I say, hey, go play with it. Okay, I don't have time to play. At being the dean, I don't have time. Yeah, this is $350.
Wow.
$350. So it's within reach. You can buy this easily and just, The other day we had a hackathon at Kean University. Okay, one of the team from high school, they brought their own Oculus, and they just programmed in Unity, and then at the end they demo their system. Yeah, the 3 students, they don't know how to write program, but they can put system together. Yeah.
Facebook has bought it?
Yeah, Facebook bought this company. Yeah. And Samsung going to come up with a system like this, but they are using Oculus engine. They borrow all the intellectual property from Oculus. Okay? There are 2 other systems. One's by Sony, I think called Morpheus. Then another one by HTC. All these are coming out at the end of the year. Okay, the production model. Okay. So that means this is the year of immersion technology become mainstream. It's going to become mainstream. I hope this plays here. Let me backtrack. So once you wear the glass, you can see what's going on in there, and as you go like this, the wall tumble down. Okay. Even without sound, you can feel pretty some sensation. Okay. If you need to feel more, then you should put some fans and blowing at you, and you can feel the sensation of crashing through the walls. Okay. So the goggle is not very expensive, $350. I mean, all of us can afford it. However, the real top of the line goggle is about $50,000. Okay, used by military. used by military. Those are very expensive. But consumer grade now is at $300 range. And all of us can afford that easily. Okay? So the next up in this type of immersive virtual reality is called, what's it called, the dome. Okay? A dome is like a screen, but it's curved. The projection system just displays onto the dome. Okay? And then you can interact with the system with multiple people in there. Okay? You have multiple people in there, and then you can interact with the system. The drawback of using a goggle is that whoever's wearing it is the only person that can see the environment. Okay? With the dome, when you're doing collaboration, multiple people can be at this system and interact with the system. Does anyone know the cost of this? The low end of this type of system, it costs about $20,000. The low end. High end is about 100K. Okay? So that is not within reach for us. Okay? Usually this type of system is used in corporations, research labs. Okay? Now,
Are they used for simulation as well?
yes,
Simulation training, I mean?
yeah. You use this for simulation, for training, for physical therapy. You can use this to, let's say you have certain phobia. You use this to treat phobia. And most of these are used in entertainment industry, especially adult entertainment. Okay, you use in gaming, used in training. Who uses a lot of this type of training? What type of industry uses a lot of this type of training?
Aviation?
Aviation, flight simulator. Okay. Pentagon.
Yes. DARPA?
Yes. Okay. Astronaut, they go through this type of simulation training. Okay. Pilot. Who else is used to have this training? Psychologist, yes. Yep.
To
Use
treat
this.
that phobia problem would
Yep.
be a psychologist.
Yep. And in a lot of police training, tactical force training, so you can introduce any kinds of scenario, then see how they respond to a scenario. Terrorism training, okay, how to fight terrorism, they use that training. Fire safety, how firefighters, when you enter a building where this person should go, what happens this room start to have fire, where do you go? Okay, so this type of training is used in this environment. So the next system up the chain of this type of virtual environment is what's so-called c.a.v.e. c.a.v.e. is an acronym for Automated Virtual Environment, Computer Automated Virtual Environment. So a cave basically looks like a cave, 3-sided or 4-sided, depending on how much money you want to invest in. Okay, and this cave, this is my own cave at my university. This was a project funded by National Science Foundation. So this is the back side of the cave. Okay, it has a projector like this. Well, this projector is a bit bigger than this one, it's about this big. Okay? It has 3 sides. It projects to a mirror, then reflects to a screen. Okay? So the projection is actually in the back, project onto a screen. Okay?
And what would be the platform? Windows?
Yes, Windows. Well, they have different platforms. They have Linux and Windows, yes. So here's the projector. This projector itself, this is alone, is 100K. 100K. So if you have 3-sided, that's 300K just on the projector.
Just for the projector?
Just the projector, yes.
It's expensive, huh?
Very expensive, yeah.
And you have this in your lab?
Yes.
You have to visit your lab.
So this is designed and manufactured and integrated by a company called MacTweak. They are the one that, these are a bunch of students from University of Illinois. They've got their Ph.D. They put together the system as their Ph.D. dissertation, and they started a company. Yeah, started a company. This is MacTweak. We got this in 2011, 2012. Okay. And we have a graphic node that uses 4 NVIDIA graphic chip or card. Okay. So in order to use the system, you have to wear goggles like this, just like you go into a 3D movie. Okay? Except there's one goggle that's very special, and that's this one. What's special about that one?
It's red.
Red? No.
It's wireless?
They are wireless, yes.
Oh, okay.
Yeah.
Well, is it a alternating LCD shutter?
It is, yes. It has battery inside all of them.
Okay.
Yeah. But that one is very special.
Give us a hint, please.
It's something different.
It has antennas.
Yeah.
Yeah, there's some
It has
like
antenna.
balls on top. There are 3 of them, right? Like this,
Yeah.
right?
Yeah.
Does anyone know what that 6 balls are for?
Orientation?
Yes. So the system has 2 cameras on top, and you can see the 6
Yes.
balls. Okay, these balls are used for the coordinates of
Yes.
the person who's wearing it. So if you move this way, the whole screen gonna shift in real time. In real time. Okay. So unlike going to a 3D movie, you sit there, you're watching the same scene. Okay. Whoever's wearing that glasses, if that person bends down, the whole screen would just move as if you are looking downward. Okay.
I mean, the whole screen then is mounted on something which sort of movable.
No, actually, the rendering is in real time, just change the scene for you right away.
That's why the 4 NVIDIA cards. Yeah.
Yes, so it's like this. So this person wearing this, so as he turns, the whole scene will just move in real time. Yeah. And look what he's holding. It's like a navigation device, like a mouse, but it's for 3D environment. So you use that as a mouse to click. So this is a guy from the company that he came here for a week just to install the system. Just to install it. So he was testing it. I was taking a photo.
So this could be used for flight simulators as well.
Yes. Yeah.
So that, you know, the pilot is looking this way.
Exactly. Yep. That's exactly like this. Yes. You can actually build one yourself. If you have 3 screens and you buy a projector like this, you can build it easily. A few $1,000, $5,000. I think you can do it. But I don't know. Yeah. Still expensive though.
Yeah.
Okay. But do you know how much my system costs?
$500,000?
Yeah, this system cost me $600,000. You can buy a house. Yeah, you can buy a house. And this is a professor from RPI. Yeah, he's in digital arts, game simulation, and he came to give a talk. I showed him my system, and he was really impressed. So, and the application that now is running is, I think, it's particle simulation. One of the professor in physics wrote with students. So they use particle simulation in there, so you can see it and see how the particle moves. It's just to test the system, see if it's working properly. And that's a human heart, an artery. So you can actually walk. As you move forward, you feel like you're walking into human heart. Okay. And you can have multiple people in this environment, like this.
So they can be used to train surgeons as well.
Yes.
Take a scalpel and he cuts it, you know.
Yes. Yep. But you need other devices to go along with this type of environment. Okay? You can use the goggle, but you need some type of force feedback in order to have that
feeling.
Feeling, yes. So here comes C.a.v.e. This is the newest system proposed by MacTweak, the company that created c.a.v.e. Okay? And this new system, I don't have one. Okay? This is, I took these two images from their website. C.a.v.e, unlike the traditional c.a.v.e, is either 3-sided, 4-sided, even 6-sided. Okay? You can have 6-sided. Okay? It's more expensive, that's all. It's just have more projector purchased. This type of c.a.v.e is round. It's round. It's like you go to World Disney, they have theme parks, and you go in there, and environments like this. Okay? And this is, according to MacTweak, this is more flexible than the traditional c.a.v.e. More flexible. Okay?
What is the clock rate of the operations?
The
Clock rate of the computer.
computer? Oh, the computer that we're using dual-core Xeon processor. Okay, the key is not in the computational power of the CPU. The key is in the rendering. It's the rendering that has to be real time, and that is all powered by the graphics processor. Yeah. So in this type of application, it's not CPU bound. It's actually graphics bound. You have to move everything in real time.
So that would be working at what, 6 megahertz or something?
I believe that the cards that I have, it was in about 1.5 gigahertz. Yeah.
1.5.
Gigahertz. Yeah, and you have 4 cards. 4 cards. Yeah. And nowadays, you can buy very powerful GPUs. Okay? It has like 500 cores in there. 500 cores. Yeah, 500 cores in there, and these are like not the same type of core as your CPU core. These are cores that are specially designed for graphical processing. Yeah. So I thought I'd borrow a video from YouTube from the company and just show you.
Did you know that half your brain is dedicated to processing visual information? This means if you're not using visualization, you may not be using half your brain to solve complex problems. Today I'm standing in the middle of a C.a.v.e. system, staging in MacTweak's Technical Center. The C.a.v.e. is a next-generation hybrid virtual reality display. It offers many benefits over our traditional C.a.v.e. and tiled walls. Think of visual displays as lenses we use to look at our data. If you were wearing a pair of glasses that had poor focus or resolution, then it might be difficult to actually see or read a book and make sense of the information there. The same is true for data displays. If the display, or our lenses, is of poor resolution, we may be drawing the wrong conclusions because we're not really seeing the content in fine level of detail. This is not the case with the C.a.v.e. The C.a.v.e. is a single multifunctional display that supports high resolution and immersive viewing. This means you can see more content and at a higher level of detail all at the same time. For example, a team of geoscientists would be looking at a variety of data: well path planning, what would have been inkjet plots, even 3D seismic, all at the same location. This allows researchers to have a complete picture of their data, a big picture, to make detailed observations and gain new insights.
Teams collaborating in the C.a.v.e. can work in a 2D, 2D and 3D, or a fully 3D immersive mode. This is made possible with MacTweak software such as Get Real 3D, Meeting Canvas, or Conduit, fostering a truly collaborative environment. Specific hardware also aids in making this a very comfortable environment. Specialized panels use remote electronics to lessen heat and noise, making this a very comfortable environment for extended periods of time. Size is also important when it comes to images that need to be displayed. Some images have a resolution that are so high, all of the detail can't be seen on a single display system. At over 72 megapixels, the c.a.v.e. is approaching the visual acuity of the human eye, providing a clearer, brighter picture. Additionally, LCD panels with thin bezels provide a near seamless image. Two more important aspects of the c.a.v.e. are omnidirectional stereo and 6-degree of freedom tracking. When in 3D mode, the gradual curvature of the c.a.v.e. allows for omnidirectional stereo to be calculated, providing a good stereo view for all users regardless if they're tracked or not. This allows for large groups to be in here, have a good stereo view, and minimizes simulation sickness. Additionally, 6-degree of freedom tracking allows users to have a correct viewer perspective or interact with their data. The c.a.v.e. also has a 20.1 surround system. By comparison, a home theater will only have 4.1 surround sound. In the end, the c.a.v.e. is a hybrid virtual environment that allows users to collaborate, view multiple data sets simultaneously, be immersed in their environments, and make better, more precise decisions.
So how much do you think a system like this is going to cost you?
$3 million.
At least a few $1 million.
$10
Yeah, a few $1 million. Okay. So far we talked about visualization. How do we immerse ourselves visually? Okay. Now, how do we interact with objects in the virtual environment? Do keyboard and joystick? Now, actually, the first thing I want to introduce to you is called a data glove. I have one of these. This is the next generation. The one I bought a couple of years ago. It's not as sophisticated. Now it's probably more accurate. Okay? This is about $600. $600. So when you bend your finger, grab something, it knows that you try to grab something. So you can interact with your 3D object. You want to grab 3D objects. Okay? But the problem with this, okay, here's my student giving a presentation. She was using a 3D glove to manipulate 3D objects in real time. Okay? So she can go grab it, and then in virtual environment, the hand would just grab the object and be able to move it around. Okay? But one problem with this type of glove is that, does anyone know the problem?
Well, you need the haptic, you need the feeling that you are holding
Yes,
something.
so it doesn't matter what you're grabbing in like thin air.
Yeah.
Okay, there's no feedback. Let's say you grab a baseball versus you grab a tennis ball. You have different softness of the object you're grabbing, so you can feel that. Okay. So this is a 3D mouse. You can manipulate object in 3D using this mouse. Okay. So this the trackball you can actually pull and press down. Okay, that's how you move in different directions.
I remember about 15 years ago, Logitech had introduced a mouse like this,
I have one.
which you could feel the pressure.
Okay.
So if you take a file, which is
Okay.
1 megabyte in weight, and when you drag that file to drag and drop, you could feel that it was heavy,
Really?
rather than a 2K file.
Okay.
I have it. I don't use it because they discontinued
Uh-huh.
the thing, and the operating system has changed.
Yes.
But they had one. I don't know why they stopped it. It was very interesting.
Yes. So this is a 3D mouse as well. So as you move, it knows what's the orientation of your movement. Because it has those trackballs, the camera can detect the position. Okay. This is by Sony. Does anyone know what this is?
Yeah. That's an electroencephalogram that you wear. on your
EEG
head,
device.
EEG,
You
get
put
your
it
brain
on
waves.
your head, so you measure your brain waves. I actually gave this to one of our undergraduate students, and he was using this to manipulate objects. He can move left and move right. Okay, and now he's a Ph.D. student at University of Florida. He's using this to fly drone. Yeah, He's coming back next week. I bought my own drone. I said, come and set it up for me. Yeah. So he could using this to fly drones. Okay. And this is a device that actually you sit down, right? You move like a rocking chair, and so that depending on the application, it will move based on the application. Okay. So force feedback, as we mentioned earlier, the 3D gloves that I showed you, okay, it doesn't have the force feedback. In order to have the force feedback, you need additional mechanism, mechanical mechanism, so that will squeeze you while you're holding an object like this. Okay? So as you touch a virtual object, depending on the type of object you touched, it's going to behave differently. So you can feel the weight. It's heavy, it's light, it's soft. Okay? So you can feel it. Okay? You got two hands. If you have this, you could do virtual surgery. You have patients on the other side of the internet, and then you do surgery from here. Okay? But you know, one of the problems now, everything's connected online. I read an article that even surgical instruments nowadays can be hacked by hackers.
Oh my God.
Oh my God.
Yes, can be hacked by hackers. Okay, and one of my faculty is doing computer security. He told me that one of the police stations was hacked by hackers, and hackers encrypt all the files. Okay? Even national security won't help the police station to decrypt them because it's not national security. Okay, so they have to pay a ransom to get it decrypted. Okay, that's big business. Okay. So I have one of these. Okay, this is about $3,000. It's a pen-like device. Okay, it gives
What's
you.
the name then, you say?
This is Phantom, Omni Phantom. Okay, it's like a pen, but it's connected with an arms that is connected to electronic devices, so that when you touch certain object, depending on the program, okay, it can feel the weight of the pen. It's very light or very soft, depending on what you're trying to accomplish. Okay, so it gives you that force feedback. Okay. And this
Same thing as a Logitech.
yes, yes. So this is good type of device for you to build prototypes that you can simulate some type of physical therapy devices. Someone's having trouble writing after a stroke. You have this type of system environment set up so that person can learn how to use a pen or use spoon.
You could quantify microtremors.
Yes, exactly. Yes.
Yeah.
Yes. And so we are creating a PT program right now at Kean University, and they are very interested. The faculty are very interested in collaborating with computer science students so that they can build applications and do research in occupational physical therapy. So this is about 3,000. Okay. So where are we going? I mean, all these virtual augmented reality devices used to be bulky, that you have to wear a backpack and the whole system is in your backpack. Then it becomes a laptop-like, then becomes a cell phone-like. Now it's like a goggle-like, right? Despite that Google's Glass didn't go anywhere. They failed, okay? But eventually there'll be another company that came up with better system in the future, okay? So eventually they wear it. Eventually you don't even have to wear it. Now there are technology out there that they embed everything into what? Your contact lenses. So you just wear contact lenses and everything's in there. Okay? So we are still at its infancy as to where this is going. But this is the beginning, because the goggle by Oculus and all these different companies going to be made available at about $300. Okay, you could just wear it and then you can write program. to control objects in 3D. Okay? If you have more money, yeah, buy those haptic devices, then you can actually feel the objects. Feel the objects. Okay? So where are we going? Okay, well, this is a photo of my cluster. I have a cluster funded by National Science Foundation as well. This is a $400,000 machine, 130 core. And I got this in 2007. So I'm using all these computational power to do a lot of computation, and they can feed into my c.a.v.e directly. Okay. This used to be the fastest supercomputer for teaching back in 2007 for teaching. Okay. It never made it to the top 500. It never made it. It's about 600 at the time. Okay. But it was the fastest machine for teaching purposes. Okay. So where are we going? Remember the Matrix movie? So see, all these perception is controlled by your brain, right? So what if you can directly tap into your brain? So you don't need any of these devices. You just tap into your brain. Okay. How long did it take to have the computer surpass human beings in playing chess? When was human beaten by computer? Do you remember?
2003.
No, earlier. 1997. That's when the Deep Blue beat the Kasparov. Yes, that was the second match. The first one, human won. The second one, well, computer got smarter. It can search a lot deeper. Okay?
I was there, I watched the match.
I was a graduate student. I was watching it right there. Okay, and at that point, that's it. Human race is done. Now, only in that particular type of game, okay, human is no longer can pass the computers. Okay, and a couple of years ago, Watson. Remember Watson? Watson beat the human Jeopardy champion. Okay, going back to the Turing machine. Okay,
Yeah.
the Turing test. Okay, you put computer and a humans in the next room, and you try to ask question and determine which one are computer, which one are human. If you couldn't tell, that means computer is as smart as human beings, right? Okay. Now, if you put Watson on the other side, you can tell which one are human because the human couldn't answer the questions. Yeah. So Watson become very, very smart. Okay. Now, how long does it take for us to see a human robot walking on the street and act intelligently like a human being? How long do you think it's going to take? But don't forget that we have autonomous vehicles, self-driving cars now, and going to already become a reality, right? 20 years ago, can you foresee this coming? I didn't. Chess, Jeopardy champion, I could see that happening, but driving cars now become reality. Okay? So how long do you think going to have the human beings, robot act like a human being walking on the street? 20 more years?
You mean aside from the robots that are already walking, Asimov and so on?
Yeah.
5 to 7 years.
By 7 years. Okay. So I think another 20 years or 30 years, you will have real robot behave like human beings walking. And they will act intelligently, and probably more intelligent than the average person on the street. Okay? But how long do you think we can achieve this? You tap into it, you're in virtual world.
More than 3 years.
50 years? 100 years?
You can't, maybe possible, right?
It will be earlier, I think.
I'll say minimum of 50 years we'll be able to do this. Yeah, 50 years we can do this. Okay, I think within our lifetime probably we could see some primitive system going. Okay, this is beyond computer science. This is understanding how your brain behaves, how it works. Okay, so this will become reality in 100 years for sure. For sure, you could do this. Okay, then what's the next level beyond this? It's the avatar, right? All these will become reality. Okay? All these become reality. And these are truly immersion because it taps into your brain directly. Smell, it can be generated through using computer and just directly tap into a neuron. Okay? You don't have to spread certain odor or mist. It just sends signal to your neuron. If you think about this, it's pretty scary.
I guess this can be done much quicker, but only if human brain can be deciphered.
Yeah.
Technology is ready, but to decipher human brain, it's a challenge. I
Yes,
guess.
you have to understand how brain works, and then you can tap into it. Yeah. But that is the future. Maybe not our generation, next generation, they'll be able to do this.
So you mean to say that in 50 years' time, we may have another Shakespeare?
We
What
might.
Shakespeare?
Yes, we might.
I doubt it.
You never know, because it's human brain is neuron to get you put together neurons. Creativity is all. It's not infinite. It's finite. It's finite. It's finite. Yeah. Any questions?
But you cannot digitize emotions.
If you can quantify emotion, then you can
That's the
digitize it.
problem.
Yes.
You cannot.
Yes. I think right now we probably need more research and understanding of how to quantify all these different aspects of human emotion. If you look at human bodies, bunch of atoms, neurons put together, okay, and it's finite. As long as it's finite, it's achievable. If it's not finite, if it's infinite, it's not achievable. Okay? It takes time.
I don't know how the perfume making companies, they classify their perfumes.
Yeah.
There must be quantification.
I know. It all
Personal
smell.
quality, I don't know
Yeah,
why.
it all smells the same to men. Smells different for females. Yeah, they have a way to quantify. Yeah.
There are 5 to 7 people in the state of New Jersey that have super noses
Yes.
that can tell that. And at the Fashion Institute of Technology, you can take a class on perfume, and by the end of the class, you will be able to identify 300 distinct volatile smells.
Possibly. I mean, there are tea tasters, I know, coffee tasters.
Yeah.
They tell the difference,
Yeah.
you know. But to quantify, I mean, it is again subjective.
Yes, it is.
Quantify is a big problem. If you could quantify the greed of human beings, Wall Street wouldn't be today what it is now. We cannot quantify it.
Yeah. More.
I have one question.
Sure.
Not long ago, I attended a talk by the Intel. Intel, one of the VP, talk about the trend of Intel computer. The first trend is connected. The computer will be connected through the network. The second thing is immersive technology. And I didn't quite understand why is the current and the near future for those computer systems, how they provide immersive technology for the computer system. Can you explain?
Immersive technology for computer system.
Right, I think so. Is there something related to virtual reality for the computer?
Yes. Well, I think that when they talk about immersion is that the computer can provide virtual reality so real, you are basically immersed in a virtual environment and you can tell what's real, what's not real. Yes, that is the future. And they are talking about their graphic engine that's going to be so superb that you can achieve virtual reality.
Okay. Does it mean that computer system will become more popular and affordable by the general customer? Because you mentioned many examples actually for the spatial purpose, for the training, education, or for other things. How about the user?
General user, consumer, right? I mean, you see the trend is changing in terms of the goggle. The goggle price is dropping. Now it's at $300 range. And as technology improves, sure, you can have even higher resolution fit into the goggle. Right now it's at high definition, that is inside the goggle. But eventually it can be 4K and even higher in the future. But one problem with the goggle is that when you wear it long enough, you actually you have headache.
So you mean that for the general user, the laptop, the desktop is not for the general user.
What?
So for the will be the goggles then.
Yes, eventually everything will be built into a goggle. That's the computer running inside.
That's good. Thank you.
For the Google Glass, right, is a visor over here that assists you. So there's a computer screen right here helping the user. I think it failed because of, first of all, is the price. Second of all, is the interface. It's not there. Okay? But eventually, I think another company will come up with a better device. And also the battery life doesn't last too long. Yeah.
Also, another question is a company like Coney, Coney and Siegel, they have the glass style computer.
Mm-hmm.
So in the many the new kind of movie,
Mm-hmm.
they also use that kind of technique
Mm-hmm.
to communicate and find the information.
Mm-hmm.
So do you have any comment for that kind of technique?
I don't have it, yes.
Okay.
Yeah. Well, I think in the future, everything you see surround you are all connected to computers. And the sensors will be embedded almost anywhere. Okay? That's why data scientist will be a very popular job in the future, because we have a lot of data being generated. So that's another area that students nowadays need to get in. You have to understand how to quantify and analyze all these data. Okay? And they're coming at a lot of volumes at once. And how do you really make use of these data? Yeah.
Well, I think there is one problem, that the proliferation of the devices.
Yeah.
That we'll have 20 of these goggles and things all over our body. The pressure on the radio spectrum,
Mm-hmm.
because radio spectrum is finite.
Yeah.
And we cannot play around with it
Mm-hmm.
too much.
Mm-hmm.
Now, as I was writing an article the other day, I discovered that even the radar spectrum,
Yeah.
which in some bands used to be the primary user, it has been declassified, demoted to secondary user,
Mm-hmm.
because the top users are given to the cell phones and
Yeah.
other things. So that's a danger.
Yes.
I mean, we all know that there was a communication failure at the 9/11 situation, and that was because of spectrum division.
Mm-hmm.
And if we have so many devices going around, you have Bluetooth and Wi-Fi and so on, what's going to happen to the radio spectrum? This is
Well, radio spectrum become a commodity that's very expensive, become a weapon. You just limit the spectrum, then you could wipe out entire city or entire nation. And digital age, spectrum is very important. Without spectrum be available, you cannot communicate. Yeah.
that's a big problem.
Yep.
People are developing things like, I was in an IoT meeting last night,
Mm-hmm.
and people are talking about devices all over the place, in the body, in the home, and so on and so forth. And BBC apparently is going to give 10,000 circuit boards away, made by ARM, to the school kids to do experiments.
Mm-hmm.
But there's a tremendous pressure on the spectrum. Now, as you know, the FCC is in charge of the spectrum in this country,
Mm-hmm.
and they have problems.
Yes. Well, as technology
Serious problems.
as technology progresses, we always find the past technology become obsolete, and then you have a lot of limitations because the usage pattern and the application changes. Okay, remember the Y2K problem?
Yes.
Because at the time when we designed those systems, we didn't foresee that it's going to reach year 2000, right? Yeah. So
Well, that problem was brought in mostly by media.
mhm.
Media went, what's going
Yeah.
to happen, and it's a marketing effort. People
Yeah.
want to sell more stuff.
Mhm.
But this pressure on the radio spectrum is real.
Yes.
That's not virtual.
Mhm.
That's a real pressure.
Yes.
So what do you do with it?
Well,
You know, if you have 2, 3, Bluetooth things in your home, they interact. If you have a 2.4 gigahertz and 5 gigahertz things to going around, 5G, they have problems.
yes. Yeah. Yeah, I know that some of the devices I try to purchase interfere with my home wireless router. Then because of the spectrum conflict.
So you interfere with Regulation 15 Subpart J of the FCC.
Yeah. So all these are
What do you
actually
do to-
good
to make
good
it work?
problems, because that means we are using a lot of devices. And as we move forward, I believe new technology will come out and you give you more throughput and be able to channel it. But that require a lot more research. And so the next generation of students, hey, this is your job.
There's Chang's job. And the students.
Well, if you don't have any questions, I thank you for coming. And if you have any questions afterwards, you can come talk to me after this meeting.
Thank you.